Okay, so this is a lesson video for 2.3, which is multiplying and dividing radical expressions. Before we start multiplying and dividing today, I just want to go and do an example from polynomials last year where you guys learned a technique called foiling. We're going to be using this technique today, so I wanted to just remind you of it with something that looks more familiar to you, and then we'll apply it to radicals later today. Okay, so with foiling, we were multiplying two polynomial terms together, or two polynomials together where they each had multiple terms. So what you want to do when you FOIL is take the first term in the first bracket and you want to multiply it with each term in the second bracket. So I'll have two terms that get created from that. I'll have 3x times 3x, and I'll have 3x times 1. Okay. Then you take your next term, in this case -1, and I'm going to multiply it to each term in the second bracket. So I'll have -1 times 3x, and I'll have -1 times 1. So we end up with 4 terms altogether, and then what you did was you just simplified it and collected any like terms. So we actually can multiply these together. So 3 times 3, that would make 9x squared. This would be 3x. This would be -3x, and this would be -1. And finally, collect like terms. Those two are like terms. 3 minus 3 is actually 0, so you don't need to write that middle term, and we get our final answer. So we're going to use the exact same technique today. We're going to be multiplying radical expressions where there's more than one term in each. So you want to take your first term, just again here, multiply it to each term in the second bracket, and then take your second term and multiply it to each term in the second bracket. And that's how you do multiplication when you have more than one term in your expression. Okay, so let's go ahead and practice this with a radical expression. We'll do sort of a simpler one to start, and then you'll see the examples that get a little bit more complicated. We're going to do this one here. You can try the others if you like there, but we'll have lots of examples to go through today. So I'm going to just actually, I don't need to rewrite it. I can just work from this one. So I'm going to do this one. So we're going to have that same technique. So I'm going to take this square root 8, the first term in that first bracket, and I'm going to multiply it to each term in the second bracket. So I'll have root 8 times root 8, and I'll have root 8 times square root 3. You can save a little bit of time if you want. If you want to multiply 8 times 8 and combine those together under one roof right away, you can. So I'm going to do that in the next step when I take my -√3. So I'm going to multiply that to square root 8, and then I'm going to multiply that to square root 3. So let's see what happens here. So I'll have negative. So you can put those square roots under one roof. So 3 times 8 would be 24. And 3 times 3 would be 9. Okay, so I got 2 from the blue and 2 from the yellow. Then your job would just be to clean it up and simplify if you can. So I'll have square root of 64 here. They can combine into one roof. So 8 times 8 is 64. I'll have 24 for the yellow one there. And I'll have another 24 and square root 9. So a couple of these I can evaluate. Square root of 64 is 8. Square root of 24 and square root of 24, these are both like radicals. They can be added together. This one has a coefficient of 1, and this one has a coefficient of -1, so they actually cancel out to make 0. And then I just have a 9 here. Square root of 9 is 3, so I end up with 8 times 3, which is exactly 5. Okay, so this is the technique we're practicing today. We're going to practice foiling with radicals. And we'll see another example in the first check your understanding. Let's go to that now. So I'm going to do the first example, example A, and if you want to try example B afterwards and check your answer down below, you can. Okay, so let's use the same technique here. I'm going to take this first term from this first bracket, and I'm going to multiply it to each term in the second bracket. And we're going to save a little bit of time by multiplying as we go. So I'll have, what you can do is multiply the numbers, the coefficients together, so the numbers on the outside. So 4 times 3 would make 12, and then the numbers inside the radicals. So 2 times 2 would make 4. Okay, so that's our first yellow one. And the second one, there's no coefficient here, so you can assume it's a 1. So I'd have 4 times -1, which is -4, and 2 times 5 under the radical or under the root, which is 10. So that's our second yellow one. Then we take our second term and we FOIL that one. So 2 times 3 would make 6. Underneath the square root, we'll have 5 times 2. And then the next blue one, the last term here, 2 times -1 was -2. And 5 times 5 is 25. Beautiful. Ready to simplify. So anything we can answer, we will. And also these two middle ones are like radicals, and their coefficients can be added together, and we can combine them into one term. So this first one here, we can actually answer it. Square root of 4 is 2, and 2 times 12 is 24. So that's exactly 24. The middle two, like I mentioned, they can be added together. -4 plus 6 is 2 root 10. I can't evaluate square root of 10. 10 is not a perfect square. And the last one, we can answer it exactly. Square root of 25 is 5, so this would be 2 times 5, which is 10. Now we're going to collect more like terms and simplify more if we can. 24 minus 10 is 14. And we can check if that radical can be simplified some more by factoring out a perfect square, but no perfect squares divide 10. So we'll have to leave it as is, and that's the simplified answer there. Okay, so if you want to try example B on your own, you can. I'm going to turn my light back on here. Okay, there we go. Okay, so in the next example, we are going to deal with square roots when we have variables. So exact same idea, we're going to FOIL again, but this time we're going to have not just numbers in our brackets, but variables also. Okay, so again, I'm going to do A, and then if you would like to try B on your own and pause the video, you can. So same idea here, I'm going to take this first term, the 7, and I'm going to multiply it with the 3 and with the -5 root B. Before we even get started though, the question asks us to identify the values for which the variable of each expression is defined. So let's look at my expression here. I've got square root of B, and I remember that square roots have to have a positive radicand. So B must be greater than or equal to 0. So before I even start, I have to state that. Okay, so let's get going with my FOILing. I'll have 7 times 3, which is 21, and 7 times 5 root B. So 7 times 5 is 35, and I'll just have a square root B. So that's the blue part. And then I'll take the next term and FOIL it with yellow. So 2 times 3 is 6, and I have a square root B there. And for the next one, I'll have -10, 2 times 5 is 10, and then square root B times square root B, I'll have square root B squared. B times B is B squared. Okay. So those are the two yellows. Okay, great. These middle ones, again, end up being like terms. You'll often find that the two middle ones are like radicals. So we'll be able to combine those together. So I'll have 21. So -35 plus 6, that is -29. I'll have -29 square root B. And I can simplify this one a little bit because the square root of B squared, B times B is B squared, so this is B. And normally we'd have to write absolute value of B, but since I've already stated that B has to be positive, putting the absolute value signs is redundant and you don't need them. Okay, so there's my simplified expression. So you could go on and try example B. If that one's a little bit more involved because you'll have to do 2 FOILing, but you can try that and check your answers if you would like. Okay, so that's multiplying radical expressions. Now we're going to move on to dividing, or what dividing looks like. So let's look at the next question here. We're going to do something, actually, we're going to go here. We're going to do something called rationalizing the denominator. What rationalizing the denominator means is making sure the denominator doesn't have a radical in it. Removing the radical or the square root from the denominator. When we do that, it makes the expression simpler. Denominator, I can't spell. Denominator. Okay, so I'll show you how to do that. There's two different strategies depending on the case. So the first examples here, we see that we have a radical expression divided by a square root in both of them. So whenever you just have one term in the denominator, we want to rationalize the denominator. And I'll show you how we do it. Rationalize the denominator. So I'll do A, and then you can try B on your own if you like. So I have 5 square root 7 plus 3 all over square root 7. So when we have a fraction, what you can do is if you multiply the top and the bottom of the fraction by the same thing, essentially you're just multiplying the fraction by 1. So you're allowed to do that and you're not actually changing the expression at all. So we can multiply this by square root 7 and square root 7. And again, that's just multiplying by 1. So we're going to multiply the numerator by square root 7. So we'll have 5 times square, so 7 times 7 is 49. And we'll have 3 square root 7. And on the bottom, when you have square root 7 times square root 7, look what happens. You end up with 7 times 7, which is 49, and we can evaluate that, and it turns it into a number, not a square root anymore. Okay, so let's just simplify this now. So on the top, we have 5 times square root of 49. Square root of 49 we can answer, it's 7, so that would just be 35. And we have 3 root 7 all over 7. So we call this simplified because the denominator is no longer a radical. It is a whole number. Okay, so that's the final answer there. So you can try part B if you like. Now, we're going to scroll down and see what happens if there's not just a single term in the denominator. So this is the strategy that you would want to use if you have a single term in the denominator. Just multiply it by whatever that term is. If you have multiple terms in the denominator, you do something called multiplying by the conjugate. So turn your page, and it's highlighted right here, the conjugate. Okay, so let's just look at the example that they have here. So let's say we had square root of 3 divided by square root of 5 plus square root of 2. So what you want to do in this case, when you have multiple terms in the denominator, we do want to rationalize it. And the way you can do that is by multiplying by the conjugate. The conjugate is just taking those same two terms, but changing the sign in between them. And I'll show you why, with a worked out example, why that works. But it is going to cancel out the radicals. So same on the top as you do on the bottom. So that's called the conjugate, when you just change the sign. Okay, so let's go to the check your understanding on the next page, example 4. So I will do the first example, and then you could try the next one. So I'm going to write it out. We're going to rationalize the denominator by multiplying by the conjugate. So I'm going to write on the side here, the conjugate of 3 square root 2 minus 4 is 3 square root 2 plus 4. All you do is change the sign between the two terms. So what I'm going to do is multiply the top and the bottom by the exact same thing. 3 square root 2 plus 4. 3 square root 2 plus 4. Let's see why that works. So I have to FOIL the top and FOIL the bottom. So this is going to be a fair amount of work here. So let's work on FOILing the top first, the numerator first. Okay. So remember, with FOILing, we take that first term, expand it in. So we'll have 12 root 2. I'm going to go fairly quickly through this, since I'm assuming we've already done some of the FOILing. 4 times 4 is 16. And then I take my next one, expand it in, 6 square root 6 times 2 is 12. And then finally, 2 times 4 is 8, so we'll have 8 root 6. Okay, and then on the bottom, we're going to FOIL. We've got 9 square root 4, and then 12 root 2. And then I'll take my negative 4, I'll have negative 12 root 2. And I'll have negative 16. Now notice, when you multiply by the conjugate, what happens is the middle two terms actually end up being identical, except one's going to be positive and one's going to be negative because of that change in sign. What happens there is that you can put them together because they're like radicals and they'll end up being 0. What you'll also notice is that the first term and the last term end up being numbers that you can evaluate exactly. So your denominator will end up being a whole number or an integer. Okay, so let's look at the denominator specifically here. Those middle two terms end up being 0. Okay, 9 root 4, that's 18. 18 minus 16, so we just have 2 in the denominator. On the top, though, I can add some like radicals together. Oh, not yet. Okay, so let's simplify anything we can. So we have 12 root 2. We have a 16. 6 root 12, I can break that up into, 12 can be broken up into 4 and 3. 8 root 6. So you should write mixed radicals if you can. So finally, we end up with this, 16. So this would be 12 root 3, 8 root 6. None of the radicals in the numerator are like, so we can't combine them, any of them together. But what I do notice is that every single one of these terms can be divided by 2. And I have a 2 in the denominator. So I can divide every single number by 2 or cancel a 2 out of every single term. You can only do this if every single term divides by 2, but we can do that. So we end up with 8, 6 root 3, and 4 root 6. There we go. And I'm just going to double check that that's the right answer. Yes. Okay, so if you want to try B, you can. And that's the end of the lesson.